Howdy everyone. In the next 2 minutes I want to explain the so-called problem of the bias variance trade-off in machine learning. This problem is usually asked on job interviews as well as explained with a lot of words and hand waving online. I believe that once you understand the math behind it, you'll immediately understand it. The machine deep learning or AI problem is a problem of fitting data into a model or a function, usually nonlinear. The model is described usually by a matrix of weight, which we will call W, and another vector of weights, which we will call B. Sometimes it's called the bias, but it's not the same bias we're talking about here. Both W and B undergoing a nonlinear transformation. Our job is to estimate to the best of our ability the parameters theta, which is a concatenation of the weight matrix, and the vector B. That's what all machine learning models are doing, period. Let's write it down. We have this linear model, Wx plus B, undergoing a nonlinear function. Our job is to estimate theta, which is W and B together. Any estimator, let's call it theta hat, is evaluated using mean squared error, and apparently we can show that the mean squared error of any estimator is the variance of the estimator plus the bias of the estimator squared. And so this is the trade-off between the bias and the variance. So if we want to minimize the mean squared error, the MSE, we need to carefully treat the variance of the estimator and the bias of the estimator, and there is a trade-off between them. And that's all there is to the bias variance trade-off.